接下来的场次，我们非常荣幸邀请到演讲嘉宾 MIPS CEO Samir Watson 先生。Samir Watson 先生将为我们带来题为"为现实世界建构以软体为先导的人工智慧"的精彩分享。For our next session, it is our great honor to welcome our speaker, Mr. Samir Watson, CEO at MIPS. Mr. Samir Watson will share his insights titled Building Software First AI for the Real World. Ladies and gentlemen, please welcome Mr. Samir Watson.
All right. Good afternoon, everyone. First of all, thank you for taking the time and being here. My name is Samir Wasan, and I lead MIPS by GF. And it's truly an exciting week for us this week because we just closed on the acquisition which we announced back in January of the Synopsys ARC portfolio. And as of this week, the MIPS team and the ARC team are one. So truly exciting times and happy to be here. So before I jump in, right, what I'm going to try and do is give you just our perspective on how we see the world. I mean, it's exciting times in our industry, how we see the world from an edge AI, physical AI evolving, and what we are doing at MIPS and now MIPS plus ARC to go uniquely position our customers to accelerate their innovation by lowering the barrier of adoption and attacking the problem from a software first perspective. Give you a sense of what the combined portfolio looks like, and give you a few examples of some customers who are starting to leverage and go forward. So let's jump in. Um, all right. Okay. So first of all, like I said, we just announced the closing of the acquisition of putting two of probably the three most legacy risk providers together. If you go back to the 1980s, late 80s, it was ARM, MIPS, and ARC which has started the risk revolution. And each of the companies have had a different trajectory. ARM is obviously well known. MIPS and ARC were doing their own thing. And essentially, just the acceleration we are seeing in semiconductors and AI has brought in together two large powerhouses of very strong legacy and very complementary expertise. When you think of ARC, you think of very energy efficient programmable cores. When you think of MIPS, historically, you'll think of very multi threaded, high performance cores. Putting these two together, we've now put together a team and a portfolio which can address the needs of physical AI right from the start to the higher end processor and AI space, all on the back of an open standard of RISC-V. So exciting time. The added benefit of being on the Global Foundry platform is that we are able to manifest our IPs and our compute solutions very quickly into process and give our customers examples of what it would look on silicon. So putting this together and truly going out and starting to accelerate our customers towards innovating and delivering on physical AI. So if you if you take a step back, I may be probably the, I don't know, 50th person standing here and saying, you know, guys, CPUs are back. For a very long time, everyone was starting to feel that everything in AI is around the GPU. And only recently have people come to the realization that orchestration, data movement, feeding the GPU or the NPU or the XPU, in many ways is one of the most fundamental problems which are being faced as customers are going out and trying to build energy efficient solutions. Now, that only magnifies as you go into the edge and the physical AI space, because the constraints of the entire system put on power consumption, on cost, are very different. So we truly feel we are at the knee of the CPU revolution, where agentic AI and agents running on CPUs are going to go redefine the entire paradigm of compute. And it's a large market already. Whatever number I put up here is probably going to be wrong, because every time someone predicts what the future is going to be, Clearly, we've been falling short of it because it just is bigger than that. So good times to start accelerating innovation on CPU. But one of the fundamental issues is our industry is fraught with a hardware first proprietary approach. At MIPS, we are a software first open approach. And why we feel the way to attack this problem of innovation and trying to get ahead of the curve is driven by letting our customers do what they want to do. For a long time, multiple decades now, we've all gotten accustomed to one proprietary architecture doing every solution. We've gotten accustomed to saying, I have a big core, I have a small core, and let me go see whether I can go build the most complex heterogeneous SoC to go do my workload. I think the time for that is gone because it does not give you optimum solutions. It does not give you optimum solutions for power, for cost, for supply chain, for vendor lock-in. It stifles innovation. So when we undertook this journey at MIPS a few years back, our approach was different. We said, let's go cater to the largest audience in our customer base, which is the software engineer. And then let's go cater to some of our customers' biggest concerns about being locked in with a vendor and give them a solution on an open standard which they are able to go operate and have freedom to compute with. And that is why our entire philosophy in the company is how do we go cater our hardware solutions to the software workloads which are necessary. What this means is the era of catalog silicon is going to get tested. I don't think so catalog silicon will disappear, but the prominence of catalog silicon is going to get tested. The advent of custom silicon is what we are going to see. We have already seen it. If you think about some of the world's largest semiconductor developers today are captive silicon manufacturers, whether it is the smartphone guys, whether it is the data center, they all do their own silicon. We at MIPS believe with an open standard, with a software first approach, and closely tying in with manufacturing capability, we can bring the barrier of adoption for customers to do their own custom silicon significantly lower. Between what we are seeing geopolitically from a regionalization perspective, between what we are seeing from an AI, physical AI coming, we predict there is going to be a significantly larger number of silicon developers out there compared to what it has been. It's been a closed garden of a few. I think it's going to be an open orchard of many. And that is the era we are getting our solutions and our approach ready for. We like to call it the Linuxification of hardware. What that means is very much like how Linux kind of freed our software developers from being tied to proprietary platforms, whether that was Microsoft, whether that was something else. Linux brought in a complete renaissance of software development and created tons of value and added trillions of dollars to the GDP. We believe Linuxification of hardware is going to do something very similar. While the cost of doing advanced node silicon devices is going up, we're also seeing the cost of developing silicon is going down because of AI. AI workflows, open standard CPU cores, open standard AI cores, and AI itself accelerating development is bringing that cost down. So if you put all of this together, what it means is if you're able to work on open standards like RISC-V, standard extensions, application-specific chips, it will translate to tens and millions of products, all catered to unique workloads, all catered on a standard which reduces and controls the total cost of ownership and manifests into a significant amount of growth in the coming years. The other thing which is changing is the decision point is changing. Tokens at the edge are going to drive needs for having intelligence at the edge. Let me give you an example. If you think of a fern tree, an evergreen fern, it stays evergreen in spite of weather changes. And one of the biggest reasons it stays evergreen is because on every leaf, it has a sensor network which sort of senses the change in weather and decides how much water it needs to pull, what are the other environmental factors changing so that it can adapt. It does not have a central decision making. So I'm one of those people who believe as physical AI goes out and gets deployed, you're going to see distributed intelligence. And for us to go cater to true physical attributes, and whether it is visual language models, whether it is metaphysical language models, it is going to just evolve where things are not going to rely on only central decision making. It is going to go out at the edge, and you're going to see agents and millions and billions of tokens at the edge making that decision. So, how do we do that? For us to go cater to this distributed intelligence and distributed decision making, the entire roadmap has to be rethought. The days of saying, here is a large application core, here is my real time core, you know what, let's go make a proprietary DSP, I think those are done. I think we've got to start thinking about what are these applications which are going to run physical AI. And we like to stay to the standard of sense, think, act, and communicate. So everything we do when we think about our roadmap is what problem are we solving? Could be a sense problem. A sense problem tends to be a data movement problem. It tends to be a CPU processing chain very close to a mixed signal. You may see in-memory compute play a very, very key role in stuff like that. You move from the digital domain very seamlessly to the analog processing domain. When you think of the think is your classic AI. Think can be small, think can be big. This is where the decision making happens in many ways. Act is, if you think about it, the distance between a camera to a control in terms of latency defines the responsiveness of the system. If we can create systems where the latency between camera and control is deterministic and small, these systems are going to look more human-like. They will be more intelligent, they will be able to react better. Act plays a very key role. A little bit of intelligence in Act goes a long way in making some of these systems work a lot more efficiently, more human-like. Communicate is at the core of it. So when we think about roadmap, we are strong advocates of moving away from big core, real-time core, embedded cores to let's start thinking of our roadmap as sense, think, act, and communicate. Next thing, as you start putting all of this together, it starts by first saying, Atlas Physical AI, what we mean by that is this is your sense, think, act, communicate paradigm. Next thing is, customers want to start writing software before their silicon is ready. Virtual platforms play a very key role. But virtual platforms which do not model behavior correctly actually are counterproductive to the development, and nobody's going to use them. So what we have done at MIPS is we've created a tool called Atlas Explorer, which allows the customers to bring their workloads. They don't need to share their workloads with us because that is their innovation. And we bring our performance models and all our CPUs virtually to them. And they are able to go run their software workload on our performance models way before silicon comes out and select what CPUs and what does their processing chain look like. It's been one of the single biggest pieces of innovation we have put in the palms of our customers, and we are seeing significant acceleration across both CPU and NPU workloads. Next thing is the portfolio of processor IP. I will show that in a second. And then being part of global helps us because we are able to manifest reference platforms. We are manifesting reference platforms as microcontrollers, and there's nothing micro about these controllers anymore. These are pretty large control-oriented devices. We're manifesting reference platforms as processors. We're manifesting ASSPs as AI accelerators. So when you go to a customer and you're able to put all of these aspects in front of them in their hands, it ultimately means you're lowering the barrier of adoption significantly, and you're giving your customers time to go accelerate and develop. So now, as I said, this is the week when we've put the ARC and MIPS portfolio together. And one of the biggest reasons to do that was that we wanted to move the discussion on RISC-V out of the academic realm into the mass deployment and adoption realm. So if you think about it, we are now the single largest RISC-V IP provider on the planet. We are the second largest compute and AI IP provider on the planet. This gives us scale, this gives us stability, this gives us an entire portfolio to start engaging with customers. And we are. If you think about our customer engagements, if I was to split it between device manufacturers, fabless companies, and captive, we are today engaged under contract or already starting to deploy and ship with more than 50 to 55% of each of the categories in these three. And the reason to do that is because no longer is the discussion about one high performance core, one real time core. It's about an end to end availability of portfolio, starting with entry level cores all the way up to high end NPUs and application cores. And each of these cores are conceived with physical AI in mind, whether it is sense, think, act, or communicate. One of the biggest examples is of our entire enablement as we were thinking about which customer to go use. I chose Apex because very large customers have a lot of resources. And obviously, we are very engaged with some of the largest device manufacturers out there. But at the same time, our entire philosophy is about driving the barrier of adoption lower. So we took the example of one of our startup customers. And this is a startup in the Bay, and it is formulated with a lot of capable people coming together. Many of them used to be ex-Tesla, some are ex-Apple. And they've come together and said, we're going to build an AI accelerator very focused on physical AI. And before we met them, they were already starting to build their algorithm on an FPGA. And their number one concern was, how do we translate what they're doing into an ASIC? Now, historically, this would have been a very, very capital intensive and time intensive platform. And it was a very good example for us to go test our philosophy. Like, have we truly brought the barrier of adoption lower? And we tested it with them. And I'm very happy and proud to say that we were able to bring in our Atlas Explorer. We were able to bring in our processor and AI IP. We were able to bring in our virtual models. We were able to bring in our entire development flow to Apex's help for them to be able to start manifesting their idea from an FPGA to an ASIC. And this is a great example because the team size at Apex is small, and it is another proof point that smaller companies, smaller entities who are trying to go innovate, to go meet their application specific needs on AI are able to leverage this and go forward. So if you summarize what we're doing at MIPS today, we have built the company on the basis of innovating on compute, getting freedom back to the customers with RISC-V, but we are starting to expand both organically and inorganically. Today, the company is able to deliver IP licensing and royalty business model. This is your classic IP licensing across CPU and AI. We're starting to engage on software. This is our software tools, Atlas Explorer, software stacks. And we're starting to offer custom silicon capabilities, translating the capabilities we have on the Atlas platform to our customers based on their needs. With this in mind, we've set our goals to be about $1 billion by 2030. And this will only be true if we are staying true to the fundamental of what we're doing, which is giving freedom back to the customers and enabling a much lower barrier of adoption for technologies and for creating your own innovation on silicon. Thank you very much. I appreciate everyone's time.
感谢 Samir Watson